Astronomers have managed to discover that super-Earths are not leftovers of many Neptunes. This new discovery challenges existing theories about the origins of exoplanets. Many Neptunes and super-Earths, which can be 4 times the size of our own Earth, are the most common exoplanets orbiting stars beyond our solar system. Until recently, however, super-Earths were thought to be the rocky cores of mini Neptunes whose gassy atmospheres were blown away. In a new research, astronomers indicate that some of these exoplanets never had gaseous atmospheres to start with. This has shed a new light on the mysterious origins of exoplanets. Their intention was to further examine the formation of super-Earths. The astronomers utilized a simulation to track the evolution of exoplanets. The model used thermodynamic calculations, which were based on the size of the rocky cores of the exoplanets. They also looked at how far they are from their host stars and how hot the surrounding gas was. According to the research team, the findings suggest that not all super-Earths are remnants of mini Neptunes. Rather, the exoplanets were formed by a single distribution of rocks, born in a spinning disk of gas and dust around host stars. It was further explained that, contrary to previous theories, their research indicates that some exoplanets can never build gaseous atmospheres to start with. Some of the rocks grew gas shells, while others emerged and remain rocky super-Earths. When researchers attempted to look at the birth or the beginning of exoplanets, it was determined that planets are thought to form in a spinning disk of gas and dust around stars. Rocks larger than the moon have enough gravitational pull to attract surrounding gas to form a shell around its core. Over time, the shell of gas cools down and shrinks, creating space for more surrounding gas to be pulled in, and will cause the exoplanet to grow. Once the entire shell of the exoplanet cools down to the same temperature as the surrounding nebula gas, the shell can no longer shrink and growth stops. Based on the research, however, for smaller cores, this shell is tiny, so they remain rocky exoplanets. The distinction between super-Earths and mini Neptunes comes about from the ability of these rocks to grow and retain gas shells. According to the team, their findings help to explain the origin of the 2 populations of exoplanets, and perhaps their prevalence, through the use of the theory that was proposed in the study. They believe that they could eventually decipher how common rocky exoplanets like Earths and mini-Earths may be. Super-Earths are a class of planets unlike any in our solar system. Super-Earths are more massive than our Earth, yet lighter than ice giants like Neptune and Uranus. They can be made up of gas, rock, or a combination of rock and gas. They are between twice the size of Earth and up to 10 times its mass. The term super-Earth is used to reference an exoplanet's size. It is used to describe an exoplanet that is larger than Earth and smaller than Neptune, but not suggesting that they are necessarily similar to our own planet. The true nature of these planets remain shrouded in uncertainty because, of course, astronomers have nothing like them in our solar system, and yet they are extremely common among planets found outside of our galaxy. Over the last 30 years, astronomers have discovered all kinds of strange and weird planets that they never knew existed and that have no analog in our solar system. Super-Earths can be up to 10 times more massive than Earth. Astronomers are still unaware of the total number of these planets that exist. and they are not sure at what point they might lose a rocky surface. But in the range of 3 to 10 times the mass of Earth, there might be a wide variety of planetary compositions, including water worlds, snowball planets, or planets that, like Neptune, are composed largely of dense gas. These exoplanets are at the upper limit of the super-Earth size limit and can also be referred to as sub-Neptunes or mini-Neptunes. Mini-Neptunes, sometimes referred to as gas dwarfs or transitional planets, are planets that are less massive than Neptune but resembles Neptune in that it has a thick hydrogen-helium atmosphere, probably with deep layers of ice, rock, or liquid oceans that may consist of water, ammonia, or a mixture of both, or may have heavier volatiles. A gas dwarf is a gas planet with a rocky core that has accumulated a thick envelope of hydrogen, helium, and other volatiles, having a result a total radius between 1.7 and 3.9 of Earth's radii. The term is utilized in a three-tier metallicity-based classification regime for short-period exoplanets. These exoplanets include the rocky terrestrial-like planets with less than 1.7 radii and planets greater than 3.9 radii. These are namely ice giants and gas giants. Like, comment, share, and subscribe. Let me know what you think about all that we have discussed in this session. Goodbye.